Hello everybody and welcome back to another episode of this series. Today I am going to do I think we are going to still work on the body allocator, but I'm going to write a few tests for it. Just to make sure that we are on the right track. So let's start by going to our build script, and I think we are going to need to create a let's call it test step, which would be I think it's something like step so name, declaration, and description, sure. So this one would be test, I think, and description will be run tests. Sure. And with this, I think I'm just going to do test step dot depend on, and I'm gonna have to pass it a pointer to some other step, which will be called run tests dot step. I think I'm gonna need to do that. Then I'm gonna create the run tests, which will be add. So which one? Create a step run with an executable build. Now, should probably be this. Options, what are our options? Root module will be source main, I think, yeah. And let's do this first. Name will be all tests, just to make sure that we are looking at the correct thing. And is there something else we'd like to have? Target, I think we'll leave as empty for now. And I think that's pretty much all we'd like to do. So let's test that. Make dash b all. Let's make sure it builds. And it does not. Expected build module in root module, of course. Of course. Yeah, so it was root source file I was trying to set. Okay, of course, and it expects a b.path of that thing. Okay, cool. So if we now go ahead and do zig build test, yeah, actually we need to go into kernel and then we do zig build test. Unknown other symbol. Oh, okay. Right, so this here is a problem. Sure, let's do it this way. We do have a tests subdirectory, so let's create a tests.zig here, and I'm just going to do const list. Actually, we can just do something like this, and here we can I guess import list, or rather tests list, and list.zig, as well as doubly linked, and whatever the other thing that was there, singly linked. Okay, so with this, it should at least give us something. Right, okay, of course. So let me do this, and this should just be something like so. Okay. Right. So if we now do, so what should we do here? Well, first of all, let me just go ahead and find all tests that I have in this here. I think we've covered all of them. Actually, we could just do import list.zig, since that already imports the other tests. Right, so let me just rebuild this. That looks good. Okay, so now that means that we can go ahead and also import our so memory. Actually, yeah, memory.zig. That's all right. And in here, so I guess we could just do this, of course, and here do tests, and go ahead and import memory and pmem.zig. Sure, let's do that for vmem and for buddy also. Sure, we don't have tests for these two here, but let's import them in any case. Okay, so that means that here we can go ahead and write our first test. Let's make it an easy test. Let's test that we got this sibling function correct on the node index. Yeah, okay. Node index sibling. Okay, so we want to create a node index, node index, which is of type node index, and we'd like to actually we need to give it a value, won't we? So this one will be so 1. Yeah. And I guess where does that belong? So it's inside of where is it defined? Inside of buddy. Oh, okay. Well, that's bad. That's pretty bad. Okay, right. It's all right. So const buddy is buddy of some sort of configuration. So this one here would be let's call it my buddy or test buddy. Sure. Test buddy node index with value of 1, and here we should do so try. Do we have stud here? Yes. So stud testing. So expect equal. So expected is 2, and actual is node index dot sibling. Okay, let's see if this runs at least. Okay. Well, okay, so missing field structure memory. Right, so const buffer, which is a let's call this a 128 bytes U8 array. Or rather, let me just remove this and just make it like so. So 1. There we go. So, and here we should have memory be, so buffer of 128. And of course, we should probably set min size also to be 1. Okay. So, expected but found const of course, probably needed to take. So I guess we don't really need to do this. We should probably just do something like so. Found const. Okay, so I guess the const is the problem. Unable to evaluate comp time expression. Okay. Right, so that's a problem. How do you go about this? Because we want this to be comp time. But this memory here being a slice, not sure we are going to be able to have that comp time. So let's do memory as a P range. Well, let's for now just do memory start U64 and memory length U64. We'll see when we get there. So now we have to take this memory as a slice, so that would be config memory. So let's do it this way. So const memory pointer is many item pointers of U8, and that would be so int, or rather pointer from int of config dot memory start. Yep. And this one here need to change to be memory memory pointer from 0 to config dot memory length. Of course. So let me put this here. And actually, let's do this. Okay, let's see. No field name memory, so okay. So now we go back here. We do memory start is so 0 for now, and memory length is 128. Hopefully we don't try to write to there, so that should be fine. So this one here needs to go. And no field name memory. what line was that? 19. Oh, well, okay, that's fairly easy. So memory length. Okay, expected 2 arguments, found 1 for bit array bit set. So where was that? Array bit set. Are the arguments, so mask and type and comp time size. Actually, I'm not sure. So let me just do static bit set. Okay, so they just use usize here. Right, so let me do that also. So U64. Oh, right. So pointer type does not allow address 0. Okay. Expect 1 array element found 0. Okay, of course. And has no member node index. Is it because it's not public? It's probably because of that. Node index public. Expect statement found public. Oh, of course, because it's not returning it. Well, that's a bummer. So I guess I'll have to put both of those inside this. And then I'll have to also put this inside of here. Is there any other way to do this? I guess I could extract this to be its own thing and have this be a public function node index of some type, well, it's not really the type that I need to take, it's more like a size. So comp time size, or rather range log, something like this. And this would need to be some sort of comp time int, right? And this returns a type, of course. And that type that it returns is this struct. Of course, here we need to add that. Right, so here we need to change this to be size, I guess, or what do they call it? Range log. Or rather, can we just take size likely and change this to size? Yeah, that looks pretty good. So that's fine. Now, bucket item index. So this one depends on node index. So now can we do public function bucket item that takes a comp time node node type, node index type, which is a type, and of course returns a type. So this one here would need to be So this. So let's just remove that and just return. And this here would be node index type. Okay. Well, that's pretty cool. So now we can define node index to be node index of what was the range here? It was something like this: max block size minus min block size. Ambiguous reference. Let's call this something like this, or rather, let's do make node index. Make node bucket item. So I guess it's gonna, yeah, type functions need to be Pascal case, but what's a good name for this? Let's just add type at the end, I guess. That's so bucket item type. Right, so now we have that. We can create bucket item, which will be bucket item type of node index. Yes, that looks good. That looks pretty good. Right, so let's try this again. Let me just clear. So incompatible types, comtime int, and whatever that is, memory. Oh, right. So that's in our expect call. That's correct. So what we are expecting is rather something like this dot value is equal to 2. Okay. So what is it saying now? Called from here. Right, so it did not recognize that. So let's do something like test body node index value 2. Okay. Let's try something else. Let's try 3, for example. Huh. Okay, wait a minute. We do have a problem. I think we're not running our tests. Okay, so let's go back to our build.zeg. Let's see what we did. Okay, so we added tests, but we never actually run them, did we? So let's call it run tests is b.run or add run artifact. And this here would need to have tests.step. So hopefully this fixes that. And it looks like it doesn't yet. Expected build step found build step. Okay. found const. Okay, so the problem is that this is const. What is it now? Found, okay, double pointer to that, so that's fine. Let's remove that. It's never muted. Okay, of course. So let me just put that back to be const. So what does it say now? Okay, so now it's failing on our test. Cool, pretty cool. So let's go back to our tests here, remove that, check that this is still failing. Yes, it is still failing. And now let's go ahead and, so what should we expect? 1, I think. No, 2. 2 is what we expect. So expected 2, but found 0. So let's see here. How do we compute the sibling? We just XOR 1. So the way we think about this is that we have a sort of tree in which we have a parent, which will be ID I. And then here we have the first child, which will be 2i, and this will be 2i plus 1. Now, if we take it from the top, the very first parent here will be 0. The first child will be 1. The second child will be 2. So I guess this one is wrong, this formula here. This one needs to be plus 2. And then this one needs to be plus 1. So that the parent is ID 0. This one is ID 1. This one is ID 2. Yeah. Okay. So I think that's the main problem we have. Right. So self.value. Yep. So this one is plus 1, and then this one is plus 2. Yeah. We'll see where we go from here, but for now that should be okay. And then this sibling here. So let's draw this again. So we have our 0 here, which is our parent. Then we have child 1 and child 2. So this one here is 2i plus 1. This one here is 2i plus 2. And that means that if we want to go from this one to this one, so I guess we could go from 2i to I plus 1 by just doing the XOR. So if we map this to this, we take so self.value, so v minus 1, and we XOR that with 1, and then we add the one that's missing here. This should give us, so this 2i plus 1 goes to 2i, the XOR puts it at 2i plus 1, and then we add 1 to that, so that gives us 2i plus 2, so that we get this. And if we do the reverse, so 2i plus 2, take 1, so that's 2i plus 1, the XOR puts us back to 2i, and then we add 1, that gives us 2i plus 1, so that should be it. So this one minus 1, and we add 1 at the end. Yeah, that should be okay. Cool. So that's working fine. Let's try some other value. Testing expect equal. So test body dot node index with a value of, so do we have any special treatment for 0? I'm expecting 0 to be 0. Yeah. Actually, let me just do something like this. Testbuddy.node index with a value of, what was the value 1? Dot sibling. And now I can just go ahead and do this, remove that, and go here and put a 0 in there, and as well as here. So, integer overflow. Okay, I'm happy with that. So 0 is so value needs to be in range 0 to size, and if we put something that's less than 0, the value overflows basically. But does that mean that we can still compute, so const comptime int, not comptime int, const value sibling, which should be an i64. Could we still, or a u64 rather, could we still do something like this? Does that save it? So what's the problem here? It has a white space on one side, but not on the other. What are you on about? Do I need to do something like value is self.value minus 1? Does that work just this? No way. Right. Maybe if we do it the correct way around, it works. Right, so now we can get rid of that. Let's check if this works. So what do we have here? Expected 0 but find 253. Okay, so this does not work with 0, so I'd rather have it crash. Let's add a special case here for 0. If self.value is 0, return self. Let's just make sure that it doesn't crash. Okay, that's okay. Let's test node index parent. Make sure it's good. Let me just copy this over. So this one here needs to have parent, and of course we need its sibling to have. So this one needs to be 0. This one needs to be 0. This one needs to be 0 also. Should we consider that the parent of 0? Actually, I'm not sold on having this as a special case. I'd rather it crashes and I know what's happening than just have this as a special case. So I will remove this. Right, so this one here is fine. Okay, so parent 1 goes to 0, 2 goes to 0, 3 goes to 1, and 6 goes to 3. 2. Okay, I can do this. Right, so it crashes on this last one here. And that's pretty okay. So if we now go to test the children, so node 0, or rather node, let's go from 0, so child left needs to be 1. Child, actually, let me just do child. Let's do left and right again. So child 40, the left child should be 1 and right child should be 2. For node 1, the left child should be 3. And for node 2, the right child should be 6. Expected 1 found 0. Where is that? 144. Oh, of course. And again, 144, expected 1, found 0, so... Oh. So the left child of 0 should be 1. Left child. Does this need to have parentheses around it? Oops. Okay, so that was the problem. So that means that now I should go ahead and find everywhere I've put a shift and put parentheses around it. So here, for example. Oh, this should be fine, I think. Right, okay. So let's try this again. Expected 1 found 2, and that's 140. Expected 1 found, of course, this one needs to be 2. And cool, no more problems. Nice. Right, so now let's test something first. Here, body bit set size. Let's just test the test body dot so I think that's the type. So let's create a body to be a test body, and that needs to be so body dot node state. Yeah, there we go. Dot count. So give the total number of bits, and this here just going to expect it to be 0. missing struct alloc. So init with an allocator. So const testing test alloc is stud testing dot yeah, something like that. This here we need to do something like so. Does that need to have init or something now? Okay, so it expect type but found comp time. Okay, so now we are going to have to deal with all the compile errors that we had before. So node ID will need to be value of 0 here. Does that work? I guess we did not return anything from here. So return body. Cannot convert union to payload type, of course. So where is that? Can we do something like this? Okay. So we have a leak in try alloc create. That's actually fine. Did the test pass though? All tests passed, but we still leaked memory. So right, let's do just something quickly here. The init takes a self, which is a pointer to ourself, and here returns nothing. And we should do self dot node state dot. I guess we allocate that on the stack. Hold on 1 second. Yeah, it's stack allocated. So that's fine. So what are the things we need to? So I guess buckets. Buckets for self buckets. Capture that as bucket, and we for every bucket we are going to create a sort of variable called iter, which would be bucket.iter, and while iter.next, capture that as a yeah, we'll capture that as a variable I'll call node, and then we can just go ahead and do self.alloc.destroy node. I'm guessing this returns nothing. Okay, so let's see if that solves our problem. Do we still leak? We still leak. So the first node is leaked for some reason. Oh, we've never actually called the init. So body.deinit. Okay. So the init takes a parameter, but it discards the const qualifier. Okay. Okay, so no more leaking. So now if we say that this should have 1, 2, 3, I believe we should at least see an error. Okay, bit set size failed, expected 1, 2, 3, and found 0. Cool. So now let's see why our bit size, or rather node states, are not fully initialized. So we need to find max order and min order and all the things between. Do we have min order? Yeah, okay, so let's first check those. Let's make this a body test. Generic body test. So let's go ahead and do body.min block size. Let's do something like body.min block size. We expected that to be 0. Since we have a memory length of 128 and a min size of 1, so the log2 of 1 is 0, so that should be that. And here we expect max block size to be 6. Found 7. Oh, right, 7. It's 7. 6 is 64. Okay, so what's the problem here? Expect 1. Okay, so it's the same issue again. Right, so now that we have these two here, why is this not initialized? Body is self, alloc. Why is this not being called? Num masks. Okay. Let's also take max order just so that we can debug it. So max order, and we'll see. So duplicate. What? Okay. I guess this needs to go there. So let's also do max order here. So we expect it to be 7 also. Yes, okay, let me just do this for now. So we do have max order set. So if I go ahead and do node state, is init empty. Does that change anything? No, still not. Why is that? So max order -1. -1. That should be 6. 5. So this should be 32 bits. Maybe does the count not give us the actual count? Oh, the bits set. Okay, so I'm actually just yeah, so it's capacity that I need to query actually. Right, so capacity should be 32, I think. Right, so now let me go back here and remove this. Yeah. Okay. Whew. That was a close one. Right, so now we know that we have the correct node state there. Let's also try to check that we have buckets dot length buckets. Yeah, I can do that, and it's a member. Of course, should have 7 of those. Should be so body dot max order -1. No, wait. Yeah, it should be max order. Cool. So now that we have that, we should be good to go. So now we can test a few other things. Let's call this body init test. Now let's create another test here for something else. I'm just going to take this since we are going to need it again. And let's do so length to bucket index. Is that something we can? So length to bucket index takes a self and takes a U64, and we can get the bucket index from there. So let's give it a length of 243, for example. This length exceeds the 128, but we should see. Empty test name must be omitted. Okay. Let's call it body. Let's call it body test for now. Unused, of course, we need to check it. So we just get that, put that here, and go ahead and do expected is so body dot test body thought bucket index with a value of is bucket index just a wrapper around U size? Bucket index, or rather a wrapper around int. Yep, it is. So let's say that we expect this to be 43, for example. And this one here is bucket index. Right, so expected U3, found U64. Okay. Let's do something like this then. Again, expected U3, found U64. In return order. Okay, well, what line was that? 93. I guess we could do something like this. Okay. So it does overflow. So what does it overflow at? Oh, yeah, because the size. Okay, so that says failing. So let's go for 73 now. Huh, it still overflows. some reason. Oh, right. So this one here expects the value to be a power of 2, basically. Okay, so now we don't overflow, but we have expected 3 but found 0. Well, that's not really good. Self-determined size is size. We multiply that by 2, and order goes -1. Huh. Should print order and size. Yeah. And we should do order and size. So, and we don't see those. It's very good. So why is that? We go here, order should be max order should be 7, so we should start from 6. Min size is 1. And we should arrive at 64 after doing a few. Actually, let's just do something like this, as well as here. And let's rerun this. Hopefully we see them. Okay. So it starts at order 5. No, actually, yeah. It starts at order 6, size 1, and then goes all the way to order 0, size 64. So hold on. There's something wrong here. We actually have a memory length of 128. So I'm expecting this to be the lowest order. So this is order so 7 or 6. Yeah, starting from 0, that's 6. And I'm expecting 64 to be order 5. Since we split this block into two 64 blocks. So that means that here I've messed up. So here we are starting from the lowest block. So block that has the highest ID, which is basically the one that has the lowest size. But why is max order not giving me the... No, actually it does. It starts from... This starts at 6. It's just that we should probably stop one step earlier. Because here we have size is less than length, strictly. So maybe if we can go less than or equal length, that should solve the problem. Let's see. No, it doesn't solve the problem. Actually, let me just add something here. Length is, just want to see what is the length we are comparing to. So we are comparing to 64. Why is order 0 64? So let's try to run this in our mind. So here we start from 0 with min size of 1. Rather, we start from order 6 with min size of 1. And if we just go ahead and draw that, so this one would need to be, we have basically 7 orders. 3, 4, 5, 6, and 7. This one here is 0, this one here is 6, right? So this one here has a 1 byte min size. This one has 2 bytes. This one is 4. This one is 8. This one is 16. This one is 32. And this one is 64. Okay, so we do have a problem then. That means that we cannot max order here is 7. I think I know what the problem is. The problem should be here. So this needs a +1. And so does this. Right. So that needs to be 7. Okay, expected 3 but found 0. Again, that's not really good. It's not great. So that means that this one here needs to be taken off. And it found 1. That's more like it. So that's what I expect this to be, order 1. So expected 7 found 8 in here. So I guess expected 32 found 64. Node state capacity. Yeah. Yeah, that sounds like it. And of course, now it should all be fine. Okay, so we just messed up the order IDs. Now let's try to do something else. Let's try to just do some generic testing on body. And I'm just going to go here, take that, and then try step testing expect equal. So let's for now say it's 0, and here we can go ahead and do test body dot node index. So const node index type of some size. So let's say no. So we actually want node index to be test body dot node index. Yeah. Okay. So here we want so we want the value. So value length is so field So field type of node ID value. Let's call this value type. And let's assert that value type dot so what was it? Value type dot int I think I'm gonna have to look this up in the documentation. So field type. Oh, so I need type info of field type. Right. Okay, so that's what I need actually. So at field info. Wait, what? Out. At type info of whatever that type is. Right. And here we can go ahead and do dot int, I think, dot bits. Yeah. And this should crash because we have a few bits. Correct. So now we should assert that this needs to be 8 bits. No. That's not it at all. So we need to encode values from 0 to 64. So we actually need 7 bits. Because this node ID here will actually have at most 64 items in it. So let's so this size here needs to have a -1 in it. No, actually, this needs to have a -1 in it. Right. Okay. Now that's sorted. So let's do the same for so const bucket ID index is test buddy dot bucket index, and const bucket type is type info of bucket index. And of course here we are going to just check that bucket type .int.bits, and this one here needs to be 3 since we have 8 buckets, but they start from 0, so we should only need 3 bits to encode them. Cool. Right, so now we need to create a node index. Should be a testbuddy.node index with a value of let's say 2. Sure. And here we are going to try set testing. So expect equal, and we expect, let's say, to, let's put it as 0 for now. Not sure what we are going to expect, but here we are going to need to do body dot, so node index from pointer, and we are going to need to pass it a, I guess, int cast of 7. So we are going to take the highest order ID, which is basically the full memory, no splits. And the pointer needs to be aligned, so we only have one choice, which is the memory start. And actually, let me just get rid of this. And can we actually add dot value here? Yes. So for this one, we expect a value to be 0. That's actually correct. So now let's go one level above that and try to go for this plus, well, let's just go for the same value. And now let's try to go for this plus 64, which is half our memory. And let's also try to go for 5. So here we have 4 splits, so I think I'm going to add 2 more. So actually, let's leave that there. And here we are going to do plus. So here we need, 32, 64, and so 64 plus 22, so that's 96. Right, so here if we go to this one here, we need to be 1. This is 0, 1, 2, and 3. Yeah. Okay, so let's run this and see. Okay, so we do have an issue. Exploit U6 found whatever that is. Oh. Oops. U6. Actually, I should make this something else. Actually, for now, let's just keep it as U6, so we know that we are working with at max 64 bits. So it's still not working. Okay, so let's try to do something else here. Let's put that there. Let's do something like start pointer here. That should be okay. And let's do const shift to be U6, and that should have a value of whatever this is. Right. And now here we can just go ahead and use shift. So expect type U6 found U64. Right, U6. Okay, so I guess we need to do int cast. Found U64. Okay, that's right. That's right. So that should be something like this with value is node index. Okay, and here we need to endcast that. Okay. So expected one found 32. That's not good. Let's try to print this step by step. Let's first do set print, set debug print. Let's just print this, and let's go for start pointer, start pointer, and we'll do the same for every one of those. So offset, offset, and actually we need to do something else here. So bucket index should be this. So bucket index, and we of course need shift. Oh wow, that's great. There we go. And this one here needs to be shift. Right, so let's think through this. Actually, first of all, let's just isolate a few of these. Make sure it still breaks. It still breaks. Right, so the first one here, and I think I did not print the info I'm looking for, which is node index. Okay, so bucket index is 7. Start pointer is 0x1000. Start pointer, let's do this. Yes. Offset is 0, shift is 0. And node ID is 0. So node ID is correct, since we are starting at the start of memory, and we basically return the full cell. Here we are at bucket index 6. Our start pointer is at 1000, but our offset is 64. So we are expecting the offset to be shifted down by a bit more than this. Yeah, okay. I think we are going to need to redraw our algorithm. So let's imagine this scenario here. We have 3 levels. So this one, and this one. So if we want to find the node pointer, node ID corresponding to this pointer here, we are going to compute the cell width. Let's call that C. So here we have 2, 1, and 0. These are the bucket indices. So C would need to be so memory length, so mem size divided by the number of cells in each bucket. Right. So memory size is 2 to the power of max order. No. What do we call that? I think it was max block size, yeah. So max block size and the number of cells in every bucket index. So here at bucket index 0, we have 4 cells. So the number of cells should be so max order minus bucket index, because we are ordering them in reverse. And so 2 to the power of that. So here we have max order is 2. Bucket index is 0. So 2 minus 0 is 2. To the 2 is 4. So that needs to go here, max order minus bucket index. And so C would need to be 2, or if we just take log of C, so let's call that log C. That needs to be log 2, of course. Of C is MBS minus max order plus bucket index. Okay, so this is the size of a single cell, and we need to take that and basically divide the memory length by, rather, divide the pointer offset by that size to get us where the pointer needs to be pointing. Right, so that needs to be offset. So shifted left, or rather right, by log 2 of C. So this is our logic. So now I think we failed to. So this is where we failed. Since we are counting them in reverse, we need to replace this here by minus MO minus bucket index. So just inverse the indexing here. Right. So this needs to be max order plus bucket index. Overflow of integer type with value -1. Should we first do the yeah, let's first do this and then do that. Or maybe I think we should do this too, since it's 0 indexed. Okay, so here shift is 5, here shift is 4, node index is 4, that's still 1 short. So here we have offset 64, and we need to divide that by 32 basically. So we need it to be shifted right by 5. So this shift here is still missing. So I think that was not needed. Oh, there we go. So expected 1 found 2. So how does this round up? So this one divided by 32. Oh, so it gives 2. So since we are 0 indexing this, we need to remove 1 from this. And we need to put this into brackets like so. So maybe we should shift it more. let me just reanalyze this and see. So here we have no problem. So we have one full block at bucket ID 7 out of 7. So max order is 7. So we take that offset, we shift it by, so we divide it by 2 to the 6, which is 64. That's not good. That is not good. We should have shifted to be divided by 128. That is not good. So this one would be minus. Oh, okay. So my bad. So it was minus max order -1. So if we just remove the parentheses, that would give us minus order +1. Okay, so now let's take a look at this again. So this one is one full block. We shifted, we divided by 128, and it gives us a 0 because offset is 0. That's cool. So here we have offset 64. We divided by, since we have 2 blocks of 64, we divided by 64 here. So it gives us a node index of 1. And now if we go back to all our remaining tests and run them, they should all go through smoothly. Yes. Okay. So just missed some things, and it snowballed pretty quickly. Whereas here in this implementation here, I can see that we've messed up the +1 again. But otherwise, we have taken into account max order. I am actually going to reorder these to have the minus at the end, just so that we can avoid problems. And here we did not really need to cast that, I think. So this one is fine, this one should be fine. Let's see if it builds. It does build. Cool. Okay, so we've saved ourselves quite a bit of trouble by doing that. So let's actually just go ahead and do the opposite, and just do so pointer from node index. Right. So node index here needs to be 0. Here it's still 0. This one here is 1. Oops, and this needs to be pointer from node index. Yeah. So this one is 0, this one is 1, this one is 2, and this one is 3. Okay, whereas the pointers should be, so 0x 1000, 0x 1000, and this one would be this plus the 64 offset, and this one would need to be 0x 1000, 0x 1000 plus 32, I think, yeah. 0x 1000 plus 64, oops, 64, no, 65, and 0x 1000 plus 96. Okay. And let's rerun this and see. Expected type node index found comp time of int. Okay, Okay, well, and I guess we should also remove all the values. Right. So how do we create node index? I guess we are going to do body test body.node index with a value of actually should already know the type, so we could just do something like and do that everywhere here. We'll go back to putting the values. So this one should be that, this one should be incremented, this one. Okay, so let's see here. Left hand side of shift must be fixed with integer type, or right hand side must be comp time known. So what is the problem here? We have bucket index, we have max block size log. Let me just do this. Okay, so this one is getting a bit ridiculous, but okay. So incompatible types. Okay. And it worked. Great. Great success. Very nice. Okay, so that's us set for now. So the only thing we need to write tests for is the actual logic in allocate, and we are going to do that next time, I believe. Well, that's all I have time for today. As always, if you've liked this video, leave a like. If you have any questions or remarks, leave a comment, and don't forget to subscribe, of course. And until next time, I'll see ya. Fucking out.